Hello, class. I hope you're doing well. Let's look at some problems from Module 5A. And this is the first problem. It says, write the resulting set using the listing method. And then we are going to take a look at this part right here. So what does that symbol mean? It's like a big U. Let's think of that as the union. Okay, this is the union of two sets. All right, what does union mean? To become one. So we're going to put those sets in one. All right, so we're going to make one set out of these two sets. Right, we're going to turn it into one. So that just means we're going to put braces, and then 4, 6, 8, 9. Okay, now I should say the braces means that we're talking about a set. What is a set? A set is it's like a list. Think of like a grocery list. Think of a ingredients list. So not the recipe, not the amount, but just listing out the items that are inside. That's what a set is. A set is like a list. And it doesn't matter what order you put them in. So I could have put them in the opposite order, and it would be an equivalent set. And notice that I'm not putting them, there's nothing doubled up, okay? So there was a 4 in the first, a 4 in the second, but we would not write 4, 4, 6, 6, 9, 8. Okay, we're going to say that this is equivalent, but we're not going to write it this way. You don't write things with more than, you're just listing the entries. You're not going to write it more than once. So that's important to know. Look at the next one. All right, this one has a U that's upside down. So notice we have this U upside down. What does that mean? So that means that we are going to see what we have in common. And this is called the intersection. Okay. And what does that mean? Well, it's what they have in common. And what numbers 3, 7, 8, 2, and 5. What numbers do these have in common? What do they have in common? What do they have in common? It doesn't look like they share anything. 3, 7, 8, 2, 5. To me, it doesn't look like they share anything. So there's nothing. There's nothing, no thing that they share. So how would you write that? Well, with sets, we're not going to write the number 0. Okay, we are not going to write do not write this as the set 0. Okay, we don't want to do this. Don't do that, because that's not what we mean. What we mean is it's the set that has nothing in it. That's what we want. The empty set. This is the empty set. The empty set gets its own symbol. The empty set has, this is the symbol for the empty set. And that's exactly what we're going to say. So the numbers that these have in common, there's none of them. So it is the empty set. The intersection between these two sets is the empty set. Right? It's kind of confusing when you get into the set theory business, but in practice, it's not too bad. Okay. Let's take a look at this one and see what happens. Write the resulting set using the listing method. And then here we have set builder notation X such that X is an odd number between 9 and 17 inclusive. Okay. Now, in your elementary algebra class, you probably learned that you could rewrite this. You don't have to, but you could rewrite this here where X is odd. Okay, that's what we're looking for. All right, so how do you do that? Well, let's just talk about what numbers we're dealing with. First one is 9, because 9 is an odd number. Then 11, 13, 15, 17. They said it was inclusive. There you have it. So that would be the set of odd numbers between 9 and 17 inclusive. So, not terrible if you know what it's talking about. Let's look at this. We have R is the set 2, 3, 5, 9, and T is 2, 5, 8. Find the following sets. Okay. So the first set they want us to find is set A is X such that X, and what does this symbol mean? This symbol means the word in. So X is in R. X is in R. X is in R. That's what that means. Or X is in T. That's what that means. So X element T, X is an element of T, X is in T. And so it's saying X is in R or X is in T. Okay, well, what set does that look like? So let's list all of the numbers that are in R or T. Okay. So X in R or X is in T would be the set 2, 3. It doesn't look like we have a 4, 5, 8, 9. Those are in X or they're in T. Right? So that's the list. But we're not going to write anything more than once. Now, what do they want here? What is this asking me about? It says R union T. All right, we talked about that just a moment ago. And what is R union T? R union T. That means we put all of the elements that are in R, all of the elements that are in T. What's that? 2, 3, 5, 8, 9. There we have it. There's the list. Note that these are the same. These are the same set. Okay, is that a coincidence? No, it's not a coincidence. So a lot of times we will interchange or for union. Okay, those phrases are interchangeable. So or, union, we're going to interchange them a lot. They mean the same thing. It's the same idea. Number 5, consider the set n of positive integers to be the universal set. What is the universal set? The universal set is the set of everything included, just like the universe. Okay, the universe is, everything inside it. That's what the universal set is. It's just the big set, the thing that includes everything. Sets H, T, E, and P are defined to the right. Determine whether they are sets H prime, E prime are disjoint. Okay, we have a lot of vocab to go over in this one. So universal set is the set that contains everything. What is this H prime here? This means we'll denote this as not H. Okay, this is H complement. We call that not H. So everything outside of H, everything outside of H is what we're talking about here. And that would be the same thing with this E complement. This is not E. Everything that's outside of E. Okay. All right. They want H and E complement. Are they disjoint? What does disjoint mean? disjoint, oops, forgot it. Disjoint means nothing in common. Okay. Two sets are disjoint if they have nothing in common. Okay, and we talked about in common, right? In common was the intersection. So that would be H and E complement. They would be disjoint if they have nothing in common. That would make this the empty set. So we're seeing, is that true or not in this case? So what is H? Okay, H is N in N such that N is greater than 150. And E is N in N such that N is even. Okay, but we need to talk about what is H complement. What is H complement? That would be N in N such that, and we want the opposite 150. Would you agree that that is the opposite? We have N is greater than 150. The opposite of that would be N is less than or equal to 150. That would be all of the other numbers. Okay. Now, what is E complement? That would be N in N such that N is even. I would say N is odd, right? If E means N is even, then I would say E complement N is odd. Okay. Are there any numbers that these two sets have in common? Is there, even if there's just one number that's in common, then this is not true. Okay. Is there any number that is less or equal to 150, which is also odd? Well, just going down 149 is less than 150, and it's an odd number. So I would say this is not the empty set, not the empty set. So you're either between this one and this one now. So no, because there's at least one odd number that is less than or equal to 150, or part D, they probably mix this up, but my part D, no, because there's an odd number that's less than or equal to 150. So I would say it has to be A, no, because there's at least one number, one odd number that is less than or equal to 150. Okay, so it has to be that. And then there's a lot of vocab about disjoint and complements, so that can be a little confusing, but hopefully it makes sense now, or maybe you'd have to rewatch the video once again. Number 6 says, find the indicated number of elements by referring to the table of enrollments in the finite mathematics class. Let the universal set U be the set of all 117 students in the class. A is the set of students from the College of Arts and Sciences. B is the set of students from the College of Business. F, the set of freshmen. And S is the set of sophomores. Find the number of students in B. Okay, so I'm looking for B. What is the number of students? Number of students in B. That's what I'm looking for. Well, what is B? B is the set of students College of Business. Okay. Well, looking at my table, here's business right there. So how many students are in there? Well, it looks like there's 62 that are freshmen, 25 that are sophomores. What if I just add these together? 5 and 2 make 7, 6 and 2 make 8. Looks like there's 87 business students. So the number in the set of B must be 87 in this example. That's fairly straightforward. Number 7 says, find the indicated number of elements by referring to the table of enrollments in the finite mathematics class. Let the universal set U be the set of all 12 students in the class. A is the set of students in the College of Arts and Sciences. B is the set of students from the College of Business. F is the set of freshmen. And S is the set of sophomores. Find the number of students in A intersect F. Okay, A intersect F. Find the number of students in A intersect F. That's what we're looking for. What is A? A is the set College of Arts and Sciences. What is the set F? F is the set of freshmen. So we want arts and freshmen. That's what we're looking for. How many are freshman arts and science students? Looks like there's just 18 for my numbers. So I would say there's 18 freshman arts and science students. Okay, fairly easy, but you have to be able to pick out the vocab words there. Number 8 says, find the indicated number of elements by referring to the table of enrollments in a finite mathematics class. Let the universal set U be the set of all 120 students in the class. A is the set of students from the College of Arts and Sciences. B, the set of students in the College of Business. F is the set of freshmen. S is the set of sophomores. Find the number of students in S union F. Number of students in S union F. Well, what is S? S is the set of sophomores, and F is the set of freshmen. Okay, so we'd want all of these freshmen and all of these sophomores. Well, how many students is that? Okay, so 15 plus 66 plus 13 plus 26. That's everybody. That's everybody, all 120 students. So the number of sophomore or freshman, that's everybody, at least in this example, right? Okay, so I think that's fairly straightforward. It says, when receiving a blood transfusion, a recipient must have all of the antigens of the donor. A person who may have one or more of the three antigens A, B, and Rh, or none at all. 8 blood types are possible as indicated in the Venn diagram, where U is the set of all people under consideration. Use the Venn diagram, indicate which the 8 blood types are included in A intersect B. So we want to find A intersect B. And over here, this is the diagram that tells us this. So this is where we're looking at it visually. So we're looking at something like this. This is called a Venn diagram. A Venn diagram. So they want A intersect B. And in this, it's A minus B minus. So where is A intersect B? That's what they have in common. That's this area right here. So right there is A intersect B. That's right here. That's what A and B have in common. So that's the two types in this problem, blood types that they have in common. So you see those right there. 10 says that we want to find A complement intersect RH. We're looking for this. A complement intersect RH. Okay, where is that? Let me draw a new Venn diagram to explain, and then I'll just highlight for this. So this is A. Let's call that B. Let's call that RH. Okay. They want A intersect RH, or I'm sorry, A complement intersect RH. Well, what does that complement do? You can think of this is how I think of it, as RH minus A. That A complement, we want to take it away. That's like the set version of subtraction. So what part of RH overlaps? What part overlaps with A That's this part, right? That's the part that overlaps. That's the part we want to take away. So if we take that away, what's left is this part, this part. So we're looking at these two. That's what we want. That's the part of RH that has nothing to do with A. So I put B positive, O positive. Okay? Number 11 says a college offers 12 introductory courses in history, in science, in mathematics, in philosophy, and in English. If a freshman takes one course each area during her first semester, how many course selections are possible? Part A here has us, if we take one of each, how many is there? Okay, so what are our categories? We have history, science, we have mathematics, we have philosophy, and we have English. Okay, how many do we have to choose from? For history, we have 2 choices. Science, we have 2 choices. Mathematics, 2 choices. Philosophy, 3 choices. And English, 3 choices. We're going to take one of each. So I'm going to multiply these numbers. 3 and 3 make 9, 18. Yeah, that's 72. Okay, that's 72 different ways you could do this. 72 possible outcomes that come out. Part B says if a part-time student can only afford to take one, introductory course, how many are possible? Okay, well, how many courses total do we have? We have 3, and 3 makes 6, 8, 10, 12. So we have 12 courses. We're going to choose to only take one. So how many choices do you have? Well, that's just 12 choices. But if you're going to take the others, how many possible ways? 72. That's a big difference there. Big difference. Okay. Hopefully that helps. Number 12 says use the given information to determine the number of elements in each of the 4 disjoint subsets in the following Venn diagram. So we have to remember what disjoint means. So disjoint means they have no intersection. Okay? No intersection. So let's think about that. Use the given information to determine the number of elements in each of the 4 disjoint subsets in the following Venn diagram. A, B, A intersect B, and the universal set is 100. Okay, I'm going to draw a separate picture, one for myself. That way I can piece this together. So I'll let this be A, this be B. Okay. They say the intersection is 25. Maybe I can. This is 25. All of A is 30. So how much would go over here? We already have 25 counted. That would be 5. We have B, which is 70. We already have 25 counted for. So how many do you have? 45. Okay, all of it is 100, right? The whole thing is 100. So how much would be on the outside of A and B? 25. That would all add up to 100, right? And then we see labeled here, these are our sections. You can see that this one is B minus A minus B, what they have in common, and then the outside. Okay. So over here, what's the number A and B? Well, that's what they share, that's 25. All right. Part B, it says find A intersect B complement. That's like A minus B. That's just the number 5. And part C says find A complement intersect B. That's like B minus A. See, that's 45. And then find A complement intersect B complement. That's like the outside of them. Found that was 25. So it's all about just labeling your pieces. Not too bad. Okay. For 13, a small combination lock on a suitcase has 3 wheels, each labeled with the 10 digits 0 through 9. How many 3-digit combinations are possible if no digit is repeated, if digits can be repeated, if successive digits must be different? All right, let's take it piece by piece. What about A here? In A, it says the 3 or the number of digits. No, nothing is repeated. Okay. 1, 2, 3. So for the first one, how many choices do I have? I have 10 digits. I have 10 choices. Nothing can be repeated. So for the second one, how many choices do I have? 9. For the third, how many choices do I have? I have 8. So this is 10 times 9 times 8. 9 times 8, 72. 720 combinations. Part B says, I'll write it down here. Part B says it can be repeated. The first, the second, third. Okay. For the first one, I have 10 choices, but that number can be repeated. So I have 10 more choices, 10 more choices. So I just have 1,000. Okay. Now, what about part C? What is the successive digits must be different? The number of the 3-digit combination possible if successive digits are different. So for the first one, I have 10 choices. Okay, but I've used one up. So I have 9. The third one, well, I've used 2, but now I could go back to the first, so I have another 9 choices. 9 times 9 is 81, times 10 would be 810. So yeah, hold on to those combination ideas. That's an important concept. And you could use the same idea to understand ATM codes, different types of passwords. 14 says which of the numbers x, y, z, or w must equal 0 if A is a subset of B. What does that mean? This A with a tipped over U. This is a subset. Okay. Do you guys remember less than or equal to or less than? So if A was a number, for instance, 2 is less than or equal to 3. This is like the set version of that. So A is a part of B. Right? So if we look at this Venn diagram over here, what would have to be 0 if all of A is inside B? Well, what's outside of B? This is the part of A that is outside B. So if that was 0, then all of A would be inside B. So I claim for my diagram that the letter X, if it was 0, then all of A would be inside B. Number 15, a class of 30 music students includes 12 who play piano, 14 who play guitar, 7 who play both piano and guitar. How many play neither student? All right, so I think what I'm going to do is I'm going to draw myself a Venn diagram. I think that will make my life a little bit easier just sorting these ideas out. How about I label this piano, and I'll label this guitar, and we'll be able to do that. All right, they told me the intersection. There's 7 that play both, so that would be a good thing to start with. There's 14 total that play guitar. I already have 7 labeled, So that's a 7. There's 12 that play piano, but I already have 7 labeled. So that must be a 5. Okay. If there's 30 total students, well, then how many does that leave? So 30 minus 5 minus 14 is 11. So there's 11 students out there. So hopefully that makes sense. If you can, you always want to label the intersection first. Okay, if they give you that information, you want to label that first. 16 says management selection of a corporation plans to fill 2 different positions for Vice President B1, B2 from administrative officers in 2 of its manufacturing plants. Plant A has 5 officers, Plant B has 6. How many ways can these positions be filled if B1 position is to be filled from Plant A, B2, Plant B? A, B. Well, how many do I have in A? I have 5. How many do I have in B? I have 6. And if I multiply those together, I get 30. So 30 ways. Part B says, how many ways can the 2 positions be filled if the selection is made without regard to plant? Okay, well, I still have 2 positions, right? But if we don't care about plants or location anymore, then how many total do I have? I have plus 6, which is 11. So I have 11 choices for the first one. I choose somebody, then I have 10. So 10 times 11, 110. So I have 110 choices there. Ways that could happen. 17 says a cable television company has 8,000 subscribers in a suburban community. The company offers 2 premium channels, A and B. If 2,500 subscribers receive channel A and 1860 receive channel B and 5,100 do not receive any premium channels at all, how many subscribers receive both A and B? So that would be the intersection. Okay, I'm going to draw a Venn diagram to sort my thoughts out here. That would be easiest thing for me to do. Label that A and that B. Okay, if we can, we always want to fill out the intersection first, but as a matter of fact, that's what we're looking for. So we can't do that. Okay, they told me that 5,100 are not in A and B at all. Okay, they're not inside at all. We have 8,000 total. All right, so how many does that leave for there to be in A or B? So that would be 8,000. 1,000. 9. Okay, so that means we've shown A or B is 29. Okay, and we know them individually, right? We know that this is A, this is B. And we know that somehow, if you put them together, you get 2,900. But we don't know how they mix. We don't know what their intersection is. As a matter of fact, that's what we're trying to find. We're trying to find their intersection. But I think if we added A and B together and we subtracted their union here, because we don't want to overcount, then what we would find is their intersection. Let me say that again. If I added A and B together, I know I would overcount. Okay, I would overcount. So if I added all of A, and then I added all of B, I overcounted. How much did I overcount by? The intersection. Okay, but if I took away the union, what would be left? What would be left would be what I want. So this is an important formula for us, but we can see that it is true. Now let's actually compute it. Okay, so A for my numbers is 2,500, 1,860 minus our discovered union. How much is that? 1460 is the intersection. Okay. And just before we move on, let me say that you can write this formula the other way. A union B equals A plus B minus their intersection. Those are important formulas for us to have. They are very helpful when we need to solve problems like this. Okay. But we can see that they are true. Group of 100 people touring Europe includes 32 who speak French, 63 Swedish, 18 speak neither. How many people in the group speak both French and Swedish? So we're trying to find the intersection. And that's the thing I told you. If you can, you always fill that out first. And that ends up being what we're looking for. Okay. So I'm going to draw a Venn diagram because I think it's just going to be a little bit easier to sort my thoughts by drawing this. So I have French, Swedish, and what do they tell me? They tell me there's 100 people total. So I'll write that down. 32 French, 63 Swedish, 18 neither. So 18 is on the outside. Okay, well, from the previous problem, we found that A union B equals A plus B minus A intersect B. That's our union formula. And I think that's going to be very helpful for us. Okay, we can just replace that with F and S, be good to go. Okay, so F and S equals F plus S minus F union S. Okay, well, how many people speak French? 32. How many speak Swedish? 63. And how much are in both? Okay, well, that would be 100 minus 18. 82. Okay. So 32 plus 63 minus 82 is 13. Okay, so we have 13 that speak both. So those formulas can be extremely helpful to us. Evaluate the expression. If the answer is not an integer, round to 4 decimals. 4, we have exclamation mark. What does this mean? All right, that means factorial. So this means 4 factorial. All right, what's 4 factorial? 4 factorial is just 4 times 3 times 2 times 1. You're just multiplying it going down to 1. Just going down to 1. So 4 times 3 times 2 times 1 is 4 factorial. All right, well, what's that? 4 times 3 is 12, times 2 is 24. But, you know, it's fairly easy to see once you know what that's talking about. So 1 factorial is just 1, 2 factorial is 2 times 1, 3 factorial, 3 times 2 times 1, 4 factorial, which we just did, 2 times 1, 5 factorial, and so on, and so on, and so on. I should mention that 0 factorial is defined to be the number 1. Okay, so we'll need that in a different formula, but 0 factorial is thought to be the number 1. Okay, evaluate the expression. If the answer is not an integer, round to 4 decimal places. We have 13 factorial divided by 2 factorial times the quantity 13 minus 2 factorial. This is the formula for 13 choose 2. Okay. 13 choose 2. This is combinations. Okay, let's see if we can evaluate. We just talked about factorial, so we should be able to do this. Let's talk about the denominator really quick. We have 2 factorial, and then 13 minus 2 is 11 factorial, 13 factorial. See if I can evaluate this. Well, I know this. Number 13, 12, 11, right? I could stop there and just evaluate. So 11 factorial over 11 factorial, cancel. 2, 12, that's going to give me 6. So really, I have 13 times 6, which is 60 plus 18, 78. Pretty easy to do that. I should mention that we can calculate combinations in the calculator. So I have my TI-83 plus here. And if I go to math, I can move over to probability. And I can choose the N choose R. N choose R. Let's see. I want 13. You're going to let me do it? No. So let's go back to math. Ability and choose R. 2. 13 choose 2 and 7. So you can do that in your calculator. And that's really helpful, especially if we have many different combinations that we need to add and multiply with. That can be very helpful too. 21 says evaluate the expression if the answer is not an integer, round to 4 decimal places. We have 21 permutation 2 divided by 21 squared. We talk about what that symbol means. 21 permutation 2 means you have 21 times 20. That's 2 spots. Okay, just 2 spots. You're just going down twice, starting at 21. So 21 times 20. Okay. Now divided by 21 squared. So that means this is 21 times 20 divided by 21 times 21. Well, we can see we can reduce a little bit here. 21 over 21. Does that leave me with 20, 21st? Okay, my choices are it's not an integer or it is an integer. Well, I'm going to use my calculator. It doesn't look like it is. Let's see. Figure this out. 20 over 21. So yeah, it's less than 1. So you can just write it in this way. We just have to round correctly. It does say round 4 decimal places. So watch out for that. One says 28 choose 5 divided by 43 choose 5. Well, that we're trying to evaluate. I say if we can, let's just see what the calculator says. Just go straight to the calculator. All right. So I want 28 choose 5. That's not what I want to do. Okay. Choose 5. 43. Choose 5. There it is. Approximately equals 0.102, and they want 4 decimal places, so that would make that a 1. Fairly easy. I mean, it's easy to put in a calculator if you know what to do. By hand, it might be a little bit more challenging. 23 says, how many ways can a 3-person subcommittee be selected from a committee of 6 people? Well, subcommittee. That sounds like order doesn't really matter. We're just making a group. Just making a group. So how many groups can you make? 3-person group or 3-item group out of 6. So that's 6, choose 3. The formula tells me it's this, and we can 6 times 5 times 4 times 3 factorial, all over 3 factorial times 3 factorial, we get rid of 1. And we know that 3 factorial is just 3 times 2, which is 6. So that's going to cancel, and you're just left with 5 times 4, which is 20. Or you can do it in your calculator. Part B says, number of ways we can choose a president, vice president, and secretary. That sounds like order matters to me. President, vice president, secretary. Right? So that's 6 choices, 5 choices, 4 choices. A little bit different. Okay, so that's 20 times 6. Well, that's 2 times 6, which is 12, 120. Okay. You could also write this as 6 permutation 3. Those are equivalent statements, but I think it'd be 120 different ways that can happen. 24 says, from a standard 52 card deck, how many 2-card hands consist entirely of red cards? Right, we have 52 cards. Well, out of 52, how many are red? Half of them are. So if I cut that in half, I have 26. I want 2-card hands. So I can do 26 and then choose 2. So 26, choose 2 is 325. 325 different ways that could occur. Okay. Hopefully that's helpful.